Hello everyone, my name's Kelvin and this is the tech I missed. I think we're going to have a really fun video today. I'm going to be showing you how to make a joystick for C64 or Atari or anything like that. But first, I want to say that I have some Lumafix boards that are done. You might, I don't know if you saw it or not, but you might have seen my video where I made a homemade Lumafix that you can do at home. And you can by all means still do that. But I went ahead and got some boards made and I put them together, and they're on sale. I think they're on my website. I'll put a link to them. I think they're like $12, maybe 14 or $12, something like that. Anyway, so yeah, if you need one and you don't want to make your own, you can order it from my website. I don't have a whole lot. Also, I'm giving away 3 to people in the US only. I'm sorry to anybody that watches this overseas. I really do apologize, but right now the channel's small and I don't have a lot of funds to be sending things overseas. So for now, it'll just be for US people, but in order to get one, you just have to be subscribed and leave a comment on this video. And I'll probably do this for until May. I'll run this because I don't have a lot of followers anyway. So yeah, so if you aren't following me, go ahead if you want one of these and leave a comment on this video, and I will probably ask again on another video. If you haven't left one on this one, you can leave one on another one. Or in any case, I'll do a live drawing of the names in May, and I'll keep you informed of when that will be. I'll just do like a quick stream, a quick stream of just pulling names out of a jar or something. So anyway, so that's that. Now let's get on to the main topic here, which is a new joystick I made for the, well, this is for the C64, but you can definitely use it for an Atari or any other system that uses this type of connector or this type of inputs for the joystick. But it's working, and it's working pretty well. I'm pretty satisfied with it. There are some things I would do differently, and I will talk about that in the end. But for now, let's get on to it. Okay, so I'm going to start with Blender here and making the case, but I'm not going to do a whole lot with it because I don't want to bore you all with Blender. But basically what I've done is I've made models of the joystick and the buttons. I took dimensions, took measurements with my calipers and got all the dimensions, got the spacing for the screws and built some mock screws there. And basically all I did was build a case around it, how I thought that would work the best or what I wanted to do. Obviously you're welcome to make your own case or not even make one, or do whatever. Yeah, so this is sort of just a quick rundown of the process of making the case. As you can see, I basically just took a cube and flattened it out and then just basically wrapped it around in angles until I had a box that fit the components, and that was, I guess, sort of ergonomic and comfortable and things like that. So yeah, so that was the beginning of the process. And in order to make the sides, all I did was select the outside edges of the box that I had made and duplicated it and separated it. You go to mesh and separate selection. Now it's its own, well, basically line right now. But then I just edited it, connected to the bottom, and then just put a face on it and then extruded it out on the x-axis to make it thicker. That's pretty much all you have to do. So you basically get an exact copy of the side, but it will be filled in. So as you can see here, I select all the vertices, then press F, and now it's a flat surface, and now I can just press E to extrude. When I put it on there, I guess I'm looking to make sure it I don't know why, but anyway, I guess I wanted to see how it looked. Anyway, you just press, I don't know, I'm trying to see how thick I want it, and then press E to extrude, and then bring it out. That's it. So you can make the sides pretty easily like that. So that's the sides, that's how I did those. So I added bevels to the top part to make it so the corners aren't sharp. So I'm going to do the same thing with the sides here. I beveled the sides to give it rounded edges, but we want it to sit flush with the case, and the side of the case is the same way, it's flat. So I just took a bigger piece, and I'm going to just do a Boolean difference with this and make it flat. So now you can see it's sort of cut, and now it's flat, so it'll rest flat against the edge of the box. And I always duplicate parts that I'm going to be working on. That might take a little bit of time, because if I'd mess something up, I might not be able to undo it far enough to get back to the original. That's why you'll see duplicates and things like that. Yeah, so that's doing the roundness of the sides, and then making sure it's squared off where it's going to be connected. And then I just add pieces to each part that I'm going to use to connect screws to, and I will eventually put holes in them and things like that. Okay, so now I've moved on, just started printing everything. Took a long time, and as you will see, I had to do it twice. No fault of the printer, it was my fault. But this is a Voxel Lab Aquila. It's very reasonably priced, and it's a pretty good printer. It's basically an Ender 3 clone. But yeah, it works really well. I'm just pointing out the fan shroud here that someone made, but I did make some adjustments too. But it's really nice because it has an extra hole where there's already a hole that you can add stuff on the actual printer itself. Okay, so the first build is done. It was supposed to be the only build, but as I said, I screwed some things up. That's the bottom. One thing which I screwed up was the holes were too small, and I did put some epoxy on the sides to keep them from breaking, but that didn't make any difference with my screws. Probably could have used some different screws and it would have worked, but I'm not sure. Screws with smaller pitches. And that, of course, is the top part. And I think this is silver silk PLA. I think it was wet. I used it before and I didn't dry it out at all before I used it. So, and I also printed it on its side, which I'm going to remedy. You'll see pretty soon. But So yeah, I mean, it turned out fine, except for those marks on the tops, and I tried to sand them out. Now what I would normally do on any other time is just sand it out and then primer it and then paint it, but since I used silver silk, obviously that's the color you want it to be, so I sort of, if I had to do it over again, I would just use just a basic PLA, because, and then just paint it, because you're always gonna, I mean, it's very hard to get a really nice flat surface that's not gonna have any issues. But this one, that one actually looks fine. But I turned the heat up as well. That was on a lower heat setting. So I made some adjustments, and so these all fit together fine. They were okay, and I'll show you here. Just put it together here. It's so we just got the top part here. It goes on really nicely. Yes, yes, the screws go there. Yes, in the back, and that's the wire hole there for the cable. And then just put the sides on there, and there we go. Fit on nice and snugly. And there you got your joystick box. Okay, straight away let me apologize for the sloppiness of this. I'm not very good at writing with my drawing pad. But anyway, so this is the pinout of your joystick port. This for the C64. I can't say what it would be for the Atari. I haven't really looked at it, but you can do that on your own if you're wanting to build an Atari one. So we have pin 1, 2, and 3, 4, 5 at the top, and then 6, 7, 8, 9 at the bottom. And that's looking at the port on the actual C64. And this would be looking at the plug of the joystick cable. So if you're looking at it face on, obviously it's going to be reverse of what's on the port. And it's going to number from right, so it's going to be 1, 2, 3, 4, 5, going from right to left, and the same at the bottom. Yes, the joy cable. Right, so what we want to do is when we get the wires out, we want to make sure that we know which wire is connected to which pin on the cable. So we're just gonna stick a something in there that can reach. Usually I just use a lead off of a resistor or something and connect it to my multimeter. Then I'll just go pin by pin, by wire, and discover which is which. So in this instance, for mine, 1 was white, 2 was, I don't know, blue, I think, but anyway. And this is what the pins do. So pin 1 is up, pin 2 is down, pin 3 is left, and pin 4 is right. Pin 5 is a potentiometer. That's for like the paddle wheel type things. So we don't need that. Cross that out. So that's not going to get used. And then 6 is our fire button. 7 is positive. And 8 is our ground. and 9 is the other side of the potentiometer, the other axis. So all we need is 1, 2, 3, 4, and 6. My cable happened to not even have a 7 and 8 or ground and 5 volts. I was going to use those for LEDs, the LEDs on the buttons, but the cable didn't have it. I could have used the input pins, but I didn't want to deal with it, so they just aren't lit. That's fine. I don't really care. But yeah, that's that. So just do continuity tests from the pins to the wires just to see which is which. Label them or write it down what color is which. I wrote it down. It was pretty easy. And I think I'll go through here and show you in a video. But yeah. So that would be the pinout. Okay, so let's get into how we're going to connect the wires to our joystick and buttons. So we have all our wires here, even though we don't have 9. We don't have the... Actually, my joystick didn't even have the potentiometer, so it only has 6 wires. Or, I'm sorry, 7 wires. So this would be our switches. We have up and down, obviously right and left. And the way this joystick works is it just has one switch. It's not a, it's normally off and then it's on, so you only have a ground and then a positive lead. However, the buttons have a ground and 2 positive leads, which would be normally on or normally closed. And you're just going to connect the, as far as the buttons go, you're just going to connect the positive into the normally open. But in any case, so these are all ground. They're all connected together. I daisy chained them all, and they're all just connected to ground. So that's all you have to worry about, and that would be pin 8, I believe. So this will go, all these grounds will go to pin 8. I told you I'm terrible drawing on this. I have to make like I'm sketching. It's just kind of too slippery for me. I don't know. Plus I'm left-handed, so I hit the buttons on the side a lot. It's annoying. It's a right-hander's world, that's for sure. So yeah, so I'm just marking 1, 2, 3, 4, pin 4, so that's going to go up. Or so pin 1 is up. So we just connect the other connector to the wire coming out of pin 1. And then we'll do the same with down, which would be pin 2. It's going to go up to pin 2. And so on and so forth. I think you understand. I'll fast forward this a little bit. Okay, so now we're on the buttons. The fire button is going to go to pin 6 by itself. So, what I'm doing here. Yeah, probably trying to remember which one it was. But pin 6. And then the up button, or if some games jump, but the up button is going to go to pin 1. Along with the up on the joystick. And down is going to go to pin 2. Okay, so here is my joystick. It's called the Zippy. and it's a knockoff from, I guess, another one that's called Zippy, because this has two Y's. Anyway, I ordered it off of Amazon probably about 10 years ago to make a cabinet for a RetroPie system. But I ended up just using those USB Super Nintendo looking joysticks. So I still had these left over. Anyway, so an easy way to tell which switch is for what is just look inside here. So you can see the switch right there. And if I push this way, I know that that switch right there is right. So that would be, I would mark that as right. In fact, I'll do it now. Okay, so we got that. Okay. So I know that that pin is right there, is right. So I'll just write R. Okay. And so if that one is right, so we want to look for left, and left is right there. Okay, so that's left. So left. And now we have up and down. So if this is left, and this one is right, this is obviously which one we want to be up. So we have to look, and it's going to be this one. Can't really see it in there very well, but that's going to be up. So this one is up. So right here, up, U. So we've got our U there, and that means U, L, R. That means this is going to be down. So that's going to be down right there, but let's just make sure. So let's see, left is this one. Okay, so up. So up is going to be this way. Oh, I had that wrong. Wait a minute. Okay. Okay. Let's see. Left. That means this is up. Up. I got up and down mixed up. So see, that's what's good to double check. So up. So let's see. Left. Left. Oh. Left. That means this way. So left is that way. That means this way is up. and that's this one, which I have marked down right there. So we have to switch up and down. Down. Now we have up and down, right? So we have left, left, left. It's going this way. Away. It goes away from the one. So left. That means if this way's left, that means this is up, and that's going to hit this one here. So we got that right now. So there's that. Okay, now with the buttons, what we're going to do is, these are for the LEDs, so we're not going to mess with those right now, maybe another time. But what we need to do is this is our ground, so we will put the ground there, and we have an option between normally open and normally closed, because this is unlike this you can have one that's if the circuit's this is basically when the button's not pressed would be here, and this is when the button is pressed. So you could have both of them if either one work. But we only really need normally closed to be connected, and so this is wrong. I meant to say normally open. You need to connect the positive output of the buttons to normally open on a normally open, normally closed button or switch or whatever you're using. So when you see NO, that's what you connect it to. And we will do the same for all the buttons. Okay, so as I've shown you in the diagram, this is going to be pin 1, and 1, 2, 3, 4, 5, and then 6, 7, 8, 9. Looking at it this way, you looking at it straight on like this. What we want to do is we want to figure out which wire is for which pin. We don't know that yet. So here we have pin 1 right here. So what we want to do is just have that on here, and I'm just going to connect ground here and turn on the multimeter. Make sure we're all the way down in there. And turn on the multimeter and go down to our continuity testing, and we're just going to find out which pin is pin 1. And I've already done this, I think. Yeah, I've already done this, so I think it's the white. I've got it written down somewhere, but I think white is number 1. We'll see. Yeah, so number 1 is white. So we need to find number 2. I think that's blue. Yes. So number 2 is blue. Okay, then we go to pin 3. And so on and so forth. You get the idea. Just find out which pins belong to which wire. Okay, and now it's just a matter of putting the components on, the buttons and the joystick. I'm doing 20 times speed here because I'm sure you would be bored watching me do this in normal speed. But in any case, once these are all on, I will do the wiring to the cable. And now I have all the wires twisted together and just slide the cable inside there. And what I'm going to do is I'm just going to add some plastic epoxy onto that to hold it in place so it doesn't come through. I put a little piece of plastic washer and then epoxy. And then you'll see that I'll have a piece of tape on it to hold it in place while it's drying. I'm doing other work. Okay, so now that I have all of the wires connected to the components, got some heat shrink tubing here, obviously to cover once I solder these, and I'm just going to solder all the wires to their proper locations. So I'm starting with the ground wire here, and from there I will just move on to the other ones. So I just holding the wire here in place, and then from the connector cable I get the ground wire, the one that I found using the continuity testing, which is what you would do, and just solder them together, and then I will do the same with all the other ones. So whichever wire ended up being up, or pin 1 on the cable, I would connect pin 1 from the joystick and the button to that. And you can use heat shrink tubing or I guess tape if you wanted, whichever you have, or whichever is most convenient for you. I prefer the tubing just simply because it's a lot easier to work with. But yeah, I clean the flux off, and then I'll heat shrink the tube here, and I will do the rest of the wires. And I'll forego showing you every single wire that I connect, because I think you get the idea. I put the heat shrink tubing over and grab my heat gun, and I thought I had a lighter. I was going to use a lighter, but I guess I didn't have one, so I used my heat gun. I'm looking for the lighter. Come on. Just get the heat gun, dude. Sheesh. Anyway, so you do the heat shrinking. Get that on there, that's good to go. And like I said, do the rest of the wires according to whichever wires you found went with each pin. And that's it. So now we put the box together. And just put the screws in here. And here comes the fun part. Wait for it. Oh, it's happening. Here it comes. Yeah. And here's the final screw in the coffin, as it were. I only made them 2mm because I wasn't sure which screws I was going to use. Yeah, that's not good. And also, I printed it like this. Yeah, I gotta figure out a different way to print this. Okay. Video is on hold until I can get this printed out better. Okay, so it took a whole day to get these done, but I redid the design and it's a lot better now. I printed it like this, and in order to avoid having supports up here. I just put lettering there, and so now it's got the supports. Still used a little bit of supports, but not as much as it would have been, and it looks a lot better than it would have with supports. So I will put the new and improved, and I made the holes bigger, and on here too. But I will put the new and improved case up on my Patreon, and it's for free. You won't have to sign up for Patreon or anything, but it'll be in a free post, so you won't have to be a member. And I'll leave one. I'll put one up with this, and then I'll put one that just says Commodore, and maybe I'll put an Atari one up there too, in case anyone wants to make one for an Atari. Or you know, and I can put a blank one there, and you can put whatever you want there. I would recommend putting some lettering there though, just because of the printing it this way. Or you could just print it this way, the way I did before, but I didn't really like the way that printed out, so this is quite a bit better, I think. So anyway, so now what we got to do is get rid of this stuff. We've got this. So we got to take this stuff off. So I'll just go ahead and do that off camera. Okay, so got everything in the new one now. All the wires are still the same. Up, down, left, right. I didn't have to undo any wires or anything, so that was good. So I brought this out a little bit, or I moved this over just a little bit, so this is over a little bit more so it doesn't hit the sides. Reduced the sides, the inside of the side panels a little bit so they're not so thick. But we'll put those on last. And now we just put this. Okay, so I'm just going to put this together here. It went on without issue. Everything's fine. Put screws in, and I put the sides in. I think it's time to wrap this video up and test it. So let's do that. Okay, so I've got C64 Doctor loaded here, and we're just going to run the joystick test on that first. Alright. Go to controller. Now we're going to go to controller. Joystick 2, that's where it's plugged in. And here we go, fire button. Up, down, left, right. And as you can see, it's all working the way it's supposed to. And that's when you press the button. Again, if you're going to do something like with Atari or so if you have a game, something like that, some other system, you want to make sure you check your pinouts, because I don't know if they're the same as the Commodore 64. So let's test the game out and wrap this video up. Okay, so this is Aliens. I don't know much about this game, but it was one I was able to get to work. I put it on floppy with my XoomFloppy that I have for sale. You can click the link down below if you need one. But yeah, so here it is, working with Aliens. I'm assuming you have to stay in those lines. Okay, so that's all for now. I hope you enjoyed this video, and I hope you make your own joystick. I'll leave a link to my Patreon in the description for files for this. You don't have to be a member. I'm just going to put it on there for free. So there'll be a post on there with files for with this and without this, and with that says Commodore, and one that has the Atari symbol and just says Atari. I could possibly, I mean, I can add other letterings if someone has another system they want me to put it to put lettering on here. But if you want to make your own, I would suggest, because I used silver silk, and I mean, it's supposed to look good on its own. Whenever you make a flat surface like this, though, you're always going to have some not great looking parts of it. So if I had to do it over again, which I'm not going to because it took forever to print, but if I did, I would have just done a regular base color and put some primer on it and painted it, because it would end up ultimately looking better. Could have sanded it, things like that. But I think it looks good, and I'm happy with it, and it works really well, and that's what really matters, I guess, the most. Anyway, that is it for this episode. Thank you very much for watching, and like and subscribe if you haven't already. Please, it helps a lot. And I'll see you next time. Take care.